let's talk about the second derivative test for relative extrema. So the whole point of this test relies on that idea that we were talking about at the very start of this lesson, that if it's concave up, so concave up is where the second derivative is positive, then we look at this point right here is going to be a max. So if we have a potential maximum or a potential critical number, if we find that the second derivative is positive, then that critical number is going to be a max. Same thing here. If I have a critical number here and I find that the second derivative is negative, then that's probably going to be a min because it's concave down, so that's going to be a minimum right there. All right, totally got that wrong. This is concave down. This is concave up. Let me try that again. Oops. Concave down, because that's a frowny face. So f double prime is negative. That's our maximum. Sorry, guys. Concave up, because that's a smiley face. Where our second derivative is positive. That's our minimum. There we go. Much better. Okay. So, here's the procedures. I am going to use my first derivative to find my critical numbers, just like last lesson. Then I'm going to plug those critical numbers into f double prime, see if it's positive or negative, and that will tell me if it's a max or a min. Now, one note right here. This second derivative test does not always give an answer. So, for example, if the second derivative is 0, that is neither positive nor negative, so at that point, you don't know. So let's try an example. Use the second derivative test to find relative min or max, so we're going to find our critical numbers of f prime first. So f prime of x is going to be negative 12x cubed plus 12x. And I want to know where that, first derivative is equal to 0 or undefined. That's my critical numbers. This is cubic, so it's never going to be undefined. However, I should have one where it equals 0. So I'm going to take out our common, or GCF. So I've got that. And then that is difference of squares, so I can factor that some more. And now I'm going to set all of these equal to 0. And solve them, so I get x equals 0, x equals 1, x equals negative 1. So those are my critical numbers. Step 2, I'm going to plug my critical numbers into the second derivative. So let's find the second derivative first. So we've got negative 36x squared plus 12. And let's plug those in. So this is step 2. Plug critical numbers into f double prime. So f double prime of 0, f double prime of 1, f double prime of negative 1. So negative 36, 0 squared is going to be 12. Negative 36 times 1 squared plus 12. That's going to be negative 24. And then of negative 1 squared, that's also going to be negative 24. So this 12 is positive, which means that is a concave up smiley face, which means that is a minimum. These 24s are both negative, so concave down, frowny face, which means these are both maximums. So I've got a relative minimum at 0, something, because it asks for the point, so I need to do the full point, and a relative max at -1, something, and +1, something. So just like usual, I'm going to plug all those into my original function to find the full point. So if I plug those into the original, you should end up with those. Okay, there we go. Let's really quickly do number 8, and then we will be all done. So in this last question, we know that g of x is a function, and we have this table here below. So let's go through our steps. Step 1, I need to find my critical numbers of g prime. So this is where g prime is 0 or undefined. So if I look at this where g prime is 0, looks like I have x is -3, -1, 0, and 2. Those are the x values that give me 0, and there's nowhere where it's undefined. So now I check them in g double prime, and that's going to tell me the concavity of these. So g prime of -3 right there is 4. G double prime of -1, -1. G double prime of 0 is 0. And G double prime of 2 is 3. So that one is positive. So that's going to be concave up, smiley face, which is going to be a min. That one is negative, so that's going to be concave down, frowny face, which is going to be a max. And the 3 is positive, so that's concave up, smiley face, which is going to be a min. Now, this 0 is not positive or negative. So because it's not positive or negative, I don't know anything about it. So I can say I'm going to have a relative min at, let's see, it asks for the points. So relative minimum is going to be at -3. Oh, sorry, misread that. It asks for the x values. So relative min at x equals -3 and +2 because g prime equals 0 and g double prime is positive. And I have a relative max at x equals -1 because g prime is 0 and g double prime is negative. So there's your second problem using a table and our second derivative test. If you have any other questions, let me know, but you should be able to get started on your assignment.